Good evening, everyone. I am Ramya Meher from UPES-CSI. It gives me an immense pleasure to welcome Suman Debnath sir to this workshop. Thank you, sir, for giving us this opportunity to host this workshop. Suman sir is currently a principal developer advocate at Amazon Web Services. So we hope you will all learn a lot in this workshop.
Hey, thanks, Ramya. So let me first share my screen. Please let me know if you are able to see my screen.
Yes, sir, your screen is visible.
Okay, great. So let me give me a moment. Let me put that in projection. Okay. So thank you so much for the whole team for inviting me. It's such a pleasure to be here, and also, I guess I work with this group of Computer Society of India before in last year, and I strongly recommend and encourage you to join the this hackathon. And I just hope that you get little bit of understanding of cloud or AWS in general, and that might help you to do your job in a much better way what you're doing now in your college or university, or if you have just recently passed out. So my name is Suman Debnath. I work with the developer relations team at AWS in India. I'm based out of Bangalore. Basically I'm from Calcutta, but I'm in Bangalore for last 10 years or so. So prior to joining to AWS, which I guess I joined in 2019, mid of 2019, so almost 1.5 years. Before that, I used to work for various companies, mostly on the storage side and network protocol. So I was more towards the chipset side of it. So my background is electronics engineering. So that's from I'm coming. So in this session for next 1 hour or 1.5 hours, we will try to focus on few of the things in cloud computing or in AWS in general. If you are not new, maybe few of the things might be a little repetitive. So I would strongly encourage you to ask questions, because I'll try to park more time towards the question answer, and I'll try to see if I can take questions if I have the answers, or else I will always come back to you with the answers. But please do ask questions. Okay. So the way that I wanted to give you an introduction to AWS is by looking into what cloud computing is, and then we will gradually go to a few of the services in AWS which are core services. Okay. Being an engineering student, I personally do not want you to focus on a particular vendor, whether it's Amazon or any other vendor, but you should just think about cloud computing as a platform. Okay, and then you can pick whatever platform you want to use. So I work for Amazon, so I will always recommend you to use AWS, but you should not be biased about any of those things, at least at this stage of your career, when you are just studying and building it up. So I personally feel that I was not that great like you all guys, that I could able to join any hackathon when I was in college, or to attend any sessions like this. All those sessions used to happen a little less, but I blame myself that I was never that passionate about all of this. So just make sure that you make best use of this 1 hour or so, because I know that you have parked your studies or other work and join this webinar. So I really don't want you to waste your time. So when you think about cloud computing, we what we generally refer to is it's not your computer, right? It's someone else a place where you are hosting your application or services. Like one typical way that you will use any compute would be you can buy a laptop or buy a server, right? So when we think about cloud, it's somewhere else, right? We don't know where it is, but it's somewhere else. All you can do is you can just request for the resource that you need, and you can get started with it. So you don't have to wait for a payment of buying those infrastructure. These these are like, you may not even experience that, but when I started my IT career or in computer science in 2007, we used to have a purchase order and all of that, and it used to take almost 3 months to get a server in our data center. Those are long back, but those things still are still there. But cloud computing give you the flexibility to get started instantly, like within a second, and we are going to see that in a moment. Now, why AWS? Amazon, I would say that there are various domains that Amazon work, and AWS is the cloud division, and this is what you are going to use if you work on cloud any day in future. So the best part about AWS is they have so much of services that caters so different problems that there will be some solution for your problem. There has to be some solution. If not, if you reach out to Amazon, and if we feel that that has a significant use case towards which we don't have any solution, we will try to make a service or some feature addition or something like that. So the way that we work in Amazon is we call it as we always work backwards. Like we from engineering and other teams, we don't come up with our services or products. The way that we do it is we hear from customers, and whatever they say, and we just listen to them, and we try to see that if that can address a wide range of customers or people, we will try to build one service around that, or feature sets, or whatever it is. So we have the broadest and the deepest platform that can help you to build your application. Now, these are like bullet points. I really don't want to get onto all of these, but essentially the meaning is, you as a developer or customer, you get the agility, right? So think about it. Let's say you have an idea, and you are a developer, and you are an architect, and you want to get started with it. So what you can do is you can make use of AWS or cloud, and you can get started with it quickly. And let's say after a couple of months you feel that, okay, that idea is not working, or you have not considered everything, you can just scrap all of them, right? So you don't have to pay for the infrastructure that you already have, right? So it's not like on-premise infrastructure, right? So it's like it gives you the ability to make your decision quickly. So you can fail fast and you can progress fast, right? So that's the agility and the elasticity that you get. Now, when we talk about elasticity, it's mostly to do with the scaling. So think about it. We all watch IPL matches, right? So I'm sure that you don't watch IPL matches or any cricket match in Hotstar now, right? With respect to when an IPL match is going on. So think about the scale that Hotstar as a company they need when they need when there is a cricket match or any match. Their traffic would be in millions of users, right? But when there is no match, their traffic would be like less than 1,000 or a few 100,000, right? So now they have to make an infrastructure which can scale like that. We can say scale up, and it can scale down based on the demand. So that is not very much possible when you think about it from an on-premise perspective. But when you talk about AWS, these things are inbuilt in all the services. So you don't have to worry about scaling up, scaling down, how many servers that you need when you have more customers, and how many servers you need to shrink or destroy when you don't have much customers. So all of these are inbuilt in all these services. So you get this flexibility and agility and elasticity when you use AWS. So now this is very important to understand when we talk about AWS. how we do this, right? So there must be some hardware, there must be some system where we store your data, or your compute resources, network resources, and all of that. So the way that yeah, we have our infrastructure is, we call it as regions and availability zone. So we have, I guess, as of today, we have total 24 regions. Okay, so these all regions are at different parts of the geography. Like in India, we have a region in Mumbai, and we are coming up with a new region in Hyderabad. So these are the two regions that we have in India. Similarly, we have other regions like Northern California, Ohio, then Singapore, etc. Right. So total, we have these many numbers of regions. Now you can think of that region as as a place where your data, AWS have their data centers. Now within that region, what we have is we have multiple data centers, because we understand that your data is very critical. Everyone's data is very critical, right? And it might so happen that a hardware gets failed, or there's some power outage in the whole city, or stuff like that. So that's why we in every region we have something called AZ, or availability zone. And you can think of these AZ as separate data center. It has a separate grid. It has different ISP provider for internet. Everything is isolated. So the idea is, at any point in time, you will not have any data loss, right? So the data gets replicated across all the AZs. So this is something that is always happen, and that always we take care at the back end, from the hardware and infrastructure standpoint. Okay, so all you need to remember is this. So you need to remember that there is something called a region. Okay, and within that region you have a few availability zone. It may be two, it may be three, or it may be even more than three. Okay, so this is something that is very important to understand, that how we actually do this. Now, you can imagine that in the whole planet, we have 24 regions, right? 24 regions. And within every region, we have two or three availability zones. So in total, we have roughly around 77 availability zone as of today. Now, this is not enough for the whole globe, right? And when we pick up a place to build our data center, or to have a region, we try to pick a city or country where we have most number of population, or it's a metro, or it's some place where we expect our customers to be in. But it may happen that, let's say you are based out of Dehradun, and you use the Mumbai region, right? So your company is based out of India, and you use the Mumbai region. Now, this is fine for your product, but it might happen that your company's website or your product is being used by some customer in Atlanta, right, or any other place, right? It can be in some other part of the globe. Now, to access your web page, or to access your application, there is some round trip latency involved. So at times it may not be good that you lose your customer because of latency. All right. So that's why we also have something called CloudFront, which is kind of an content delivery service. You don't have to understand all of that at this point, but you can think of it as a caching place. It's not a fully blown data center, but what it gives you is, we have lots of content delivery center across the globe where we don't have regions. So you can think of these red points as content delivery zones, or Amazon CloudFront, to be very precise. So what happens is, when your customer, let's say you have your customer here, okay, and he is trying to access your web page, and you have hosted your application in the Mumbai region. Now, what it will do is, it will try to search for your data in this cache. So this is the nearest a CloudFront distribution, or content delivery network we have for this particular customer. If there is no data available for your application, then it will go to the actual place, or the origin, and then it will go back, and it will save this data here, and then it will serve your customer. So the next time, if someone else try to access the same application or same data, it can get it from here. So it's very much similar to how caching works in the way that you can think of it as how caching works in any Linux system, right? You have L1 cache, L2 cache, L3 cache, and then RAM, and then you have your spinning drive or SSD. So when any operating system try to search for a data, it will try to search the processor will try to search it in L1 cache. If there is no data in L1 cache, then it goes to L2 cache. If there is no data in the L2 cache, then it goes back to the RAM. And if that data is not there in the RAM, then it goes to the hard drive. So similar concept here. It will try to search in the in the CDN, which is the CloudFront, and there is also something called global caching. So which is in the middle, somewhere in the middle. I did not show that just to avoid some clutter. So you can think of this as an L1 cache, and this is like an L2 cache, and this is, or you can think of it as a memory, and here is the actual SSD. Okay, it's a very bad analogy, but you can. I just want you to build an intuition of how our infrastructure is built. Okay, so we have regions, we have availability zone, and we have CloudFront for caching. So these are not data centers. This is just to cache your data. Okay, so that way all of your customers across the globe can get the best in class performance. So I'm going to show you some demo now, because this presentations are quite boring. Even I feel quite sleepy at times. So let me just show you a few of the things in the demo. So before that, okay, so I hope I'm good. Okay, so this is the AWS console. So if you have never logged in to AWS console, once you log in or once you create your account, you will end up in this page. Okay, I'm just increasing the font, and I'll show you how you can create an account and all of that. But this is the regions that we just discussed, right? So we have regions in US area, we have region in Africa, in APAC or Asia Pacific. You see that there's a region in Mumbai, and within this region we have availability zone, which you don't see it here, but we do have. Okay, so I've logged in with my credentials, and this is the first window that you would see. You may not see this recently visited service because I've been using, so I see all the services that I've used. So we have not yet discussed about services, but I want to show you the first service that most of the people use to get started with, and that is called S3. Okay, so now what is services before we jump in there? So in AWS, we have lots of services, right? So if you let me just zoom out a bit. Yeah. So if you see here, I just clicked on the services, and we have lots of services for different types of work, right? So we have different services for compute. That means that if you want to have a virtual machine or any serverless platform, we are going to discuss what serverless is. You can click here or any of these services. Then we have lots of services for storage, then database, then machine learning, etc. Okay, so now we are going to start off with S3. So S3 is our object-based storage. So the way you can think of S3 is just like how you use a Dropbox, right? But it can do a lot more than just a Dropbox or any object storage that we have. So here, what you can do is you can just create a bucket, and you can store your data. So you can think of bucket as a folder, and which is not actually, but you can just think of it as a folder, and then inside that you can dump your data. Okay. So the reason that it is not as like a folder is because it has a single namespace. Okay. So in Linux, you might have seen, or you might have learned that we have file system, and then you have directories, and then subfolders, subdirectories, and then you have file. So you have a hierarchy, right? So here what happens is something like this. So let me just show you. Okay, so let's say you have a bucket name demo. Okay, so and inside that you have a folder called F1, and then inside that you have another folder called F2. Inside that you have some file. Okay, so in Linux, you would say that okay, this is the root file or folder or root directory. This is a subdirectory, and this is again a subdirectory, and then this is a file, right? But in S3, what happens is uh, this becomes your bucket. So bucket becomes this, okay, and then this whole thing, okay, this whole path, okay. So you can think of it as this: the whole path. This whole path is your object. Okay. So now if you have, let's say this is file one, let's say you have another file called, let's say, file two. Okay. Then this is again another object. Okay. So you can imagine that these are all folders, subfolder one, subfolder two, and then you have file. But the way that data is getting stored in S3 is it just knows that this is a bucket, and this is the first object, this is the second object. Okay, so this is how the metadata is stored, in the backend. So you can think of bucket as folders, and then you can create sub buckets, subfolders, and then finally your file. But internally, and these all are objects. Okay, so we store the whole the path as the metadata. So that's why we call it as a root or single namespace, right? So let's say you have created a bucket called demo. Okay, so I can create another bucket called demo2. Okay, now within AWS, these two are global, should be globally unique. That means if I create a bucket with a name called demo, you cannot use that. So that's why we call it as a single namespace, because it's global. I mean, it's unique. Okay, so let me now show you in action. So let's say you want to create an bucket, and we are going to use CLI, but before that, I'll just show you in the UI because it's little easy to understand. So I click on create bucket, and then you can give some name. So let's say I give the same name, demo, and I'm very sure that this demo would be used by someone. So let's try this. Okay, I just scroll down and click on create bucket. You will see that it says that the bucket with the same name already exists, right? So let me try bucket demo 123, and then try to create bucket again. Says that it's existing, same name exists, right? So let me give some try to get some randomness. So this is kind of very random, right? So now if I just scroll down and click on create, it would probably get created because this is quite an unique name. So if you see, this bucket got created, and now if I just filter with this, you can see this bucket. Okay, and now you can upload your file here, and now this file would be available, will be accessed, can be accessed to anyone on this planet, right? Provided that you have given enough permissions that your bucket is globally available. Now, the way that you can access this bucket is through an HTTP. You will get a full link, which we are going to see now. But I just want to give you an intuition of how you can create a bucket. And you can even create a folder, just like how we have seen, right? F1, you can create a folder, and now you have this F1 folder, right? Similarly, you can create another folder, and you can keep on adding subdirectories. But always remember that these are not folders. This is actually a single namespace, and we store the object as we just discussed. Okay, so now in the demo, what we are going to see is we are going to host a website, okay, on S3. It's a static website, but on S3. Okay, so we need an HTML file. So let's try to do that. So for this, I would like to show you another service called Cloud9. So I did not put this all in PPT because it's a little boring to see in the PPT. So I just thought to show it in the console. So let me click on Cloud9. I guess it's already opened in the tab, so I am not clicking here. So I'm just switching over to this Cloud9 tab. So what is Cloud9? So you might think that you are a developer, and let's say you travel across various places. So you always carry your laptop, right, for your development work or for your official work or college work, whatever it is, right? But uh, wouldn't that be great that if you have your development environment on the cloud and you can start doing it just like just from anyone's computer by logging in, right? So that's what Cloud9 is about. So Cloud9 is an fully integrated IDE on the cloud. Okay, so let me just try to create an Cloud9 instance, so that you get an intuition of what it is. So if I click on create environment, I already have one which I'm going to use, but I'll just show you how I have created this. All you can do is you can just create an environment for you. So let's say my dev environment. Okay, click on next step, and here you can select what type of machine that you want, and we are going to see a demo on EC2 instances as well, but you can think of it as EC2 is nothing but a virtual machine on AWS, right? So elastic compute, so it is nothing but a virtual machine on AWS. So you can select what type of machine that you want. So let's say I want a machine with 2 GB RAM with two virtual CPUs. Okay, and I want Linux 2, Amazon Linux 2 as an operating system. We support only these three operating systems for Cloud9, but when you create a virtual machine independently, not as a Cloud9 environment, you get lots of operating system options, including Windows, Linux, and even Mac. And then you can just click on next step and click on create environment. Okay, so if I just click on create environment now, what is happening now is it is trying to create a virtual machine in the backend, and it will also create an IDE kind of environment where we can just go and start writing our code. Okay, and it will give us a nice looking IDE where we can edit files, edit our code. It has an integration with Git as well, and you don't have to worry about your laptop or your development environment. You can just use Cloud9, and this has the ability to go to hibernate when you are not using. So let's say after this session I will not use it, so I don't have to shut it down. It will automatically detect that, okay, this has been 30 minutes that this guy is not doing anything, let me go to hibernate mode, so that you don't have to pay while this instance is running on the cloud. Okay, so that's about Cloud9. So let me now again go to Cloud9, and this is getting created, right? This is what we have just started, but I already have a dev station, so I have opened it in another tab. So this is the Cloud9 environment that you get. Okay, so in the left hand side you can see the Explorer kind of a window where you see all the folders that you have, and then you have a command line here. Okay, and then you have an editor here. So for this demo, I have a Git repository where you have all these demos which we are going to discuss now. So you can always go back and do that, if you feel like. So what we are going to do is first we are going to do an S3 demo, the static web page hosting, right? So for that, we will go to. I have a README file. Let me open that so that you can also see. So first is I can go to this particular folder. It's just inside this. So I've just, I hope this font is okay for you. Okay, so now inside this folder, there is, we have one HTML file, and this is our static page, okay, and which we want to host on S3 as a website. Okay, so for that, what we have to do is first we have to create a bucket. Okay, we have already created a bucket using UI. We can always use that, but I want to show you how you can create a bucket through CLI. Okay, so the way that you can create a bucket in via CLI is using AWS CLI, which is by default gets installed when you create an Cloud9 instance. But if you are working from your laptop, then you have to install it. Okay, and after you install, you have to make sure that you configure the CLI, so that you give the username, password, and all of that, just like how you configure Git, right, in your laptop. So it's very simple and straightforward. So the way that you can create a bucket is saying AWS S3 MB, which stands for make bucket, and then you give S3 colon front slash and then the bucket name. So let's give this bucket name, and let's see that if it's a unique one or not. Okay, it seems that it got created. So if we want to see, we can go back to our uh, S3 console, and we can search about that bucket. Okay, so let me click here, and you see this bucket is there, and it got created just now. Okay, so we created our bucket, right? So now let's so this is the environment which we just created, so it got created, right? So I'm just closing this because we are not going to use this. Okay, so we created this bucket. So next is we have to copy this index.html file into this bucket. So the way that we can do it is through AWS S3 CP command. It's very similar to how you use a typical Linux command, CP command. So it's quite resonating. It's almost same. So what we are doing is now we are copying this file to S3. So now if you come to S3 again and get inside this folder, you see that this file is there. Okay. So now we are done with our index page in S3, right? So now how we can create a how we can create a web page. Now there are different ways that you can create a web page. Okay, so let me show you the first one, which we are not going to do, but I'll show you how you can do this. So if you come to properties of this particular bucket, if you scroll down, you will see there is an option called static web page hosting, okay, which is disabled. So if you edit here and click on enabled, then what happens is it will ask you for giving the index file name. So it will give you what it is going to do is it is going to convert your bucket into a web page. Okay, and for a web page, it needs an index.html file, and it also needs an error.html file, which is optional. So that file will be used only in case of any error. So you can provide this index.html, and then you can save these changes. And once you do that, it will give you an complete HTTP link. But what would happen is, in that case, your HTTP link will have your bucket name in it. Okay, so it's from security standpoint, you are exposing your bucket name to everyone on this planet, right? So which is not good. And also there is another drawback for this, and that is what we have just discussed, right? That if your data is stored in Mumbai, then to access this data from US, it will take a lot of time, right? So there should be some better way, right? So let's say this particular bucket is we have created in Mumbai region. Now let's say if someone try to access it from US, it will take a lot of time. So and we discussed that we have a solution for that called CloudFront, right? And we are going to use CloudFront to create this static page. So this is one way that you can create, but we are not going to create because it will expose this bucket name. So we are going to use CloudFront. So let's go to CloudFront. Okay, so it's getting open. Now I've already created a distribution, but I'll tell you what a distribution is and all of that. So in CloudFront, what we need to do is we have to configure CloudFront, right? That okay, what S3 bucket I should cache, because it's a content delivery network, right? So it will try to cache things. to various places across the globe. But before that, we have to tell CloudFront that what bucket to cache or what bucket to look into. And that configuration is nothing but we call it as a create distribution or distribution. So let me walk you through this. So I click on create distribution. You can click on create get started, and you can give the origin domain name. So this is the bucket name which we have created. Okay. So if you remember our bucket name, what was our bucket name? It was my S3 demo 2021 123. So let's search for that, and you see this. We got that bucket name. Okay. And then what we have to do is we have to tell that, hey, I don't want my bucket to be accessed by anyone except CloudFront. All right. And that's why you check this button called restrict bucket access. Okay. So that means that I'm telling CloudFront that to make sure that my bucket should not be accessed by anyone else except you. Now, when I say you, that means I'm referring to someone within CloudFront. But who is that person? And that person is nothing but, we call it as origin access identity. Okay, you can think of it as a user. Okay, so you can always create a new identity. It will randomly create an identity, but you can also use an existing identity. So I have already created one, but you can always create a new identity if you don't have. So I've just created a new, chosen a new identity. Okay, so now what is happening is I'm telling CloudFront to look for this particular bucket, and I'm telling him that don't make sure that it doesn't have, this bucket doesn't have any access except me. And who is that me? That me is nothing but this origin access identity which I've selected here. Okay, now I also want that this access control policy gets replicated to the bucket, so that my bucket also knows about that I'm doing this, right? So you can always edit the bucket policy separately, but this is the best way to do it. So I did not discuss about policy. So in AWS, everything is about IAM or identity access management. Like every service, we secure with some policies. Okay, so policies are just like how this English word means. We need to define some rules, right? So let me show you that rather than just telling you what it is. So if I just click on this bucket, and if you come to permission, and if you see here, the bucket policy is now empty. Like there is nothing in this bucket which we have defined, right? Like who can access the objects within this bucket and who cannot access this object within this bucket. We have not defined anything. So in this option, right? In this option, what we are saying is whatever access control I am defining here, just update that same thing in the bucket policy. Okay, so that's what we are clicking here. And there are a bunch of different parameters, but you don't have to worry about all of that. But few basic things that we can change is we can redirect HTTP to HTTPS. And then one more thing that there are a lot of things that you can do because it's a caching service. But for us as of now, what we really want to do is to create a static web page using CloudFront, right? So what else we need to do here is we need to say that what should be the default object. So we already know what is that default object. That is index.html. This is the file, right, which we have just copied, index.html. So we know that this object exists in the S3 bucket. So we want that this file should be hosted, okay, when anyone access the link, okay, and that link will be provided by this CloudFront. So if you scroll down, you will find an option called create distribution. So let me create this. Now, if I just, it will take some time. If I now click on distribution, you will see that this is in progress. Okay. Now, this will take a little bit of time because, a lot of things it need to do. It need to update that S3 bucket policy. it need to cache the data in all the regions across the globe and make a website available for us, right? So it will take a little bit of time, but if after some time, if we just refresh this page, once this is done, if you refresh this page, we should be able to see the bucket policy, and you can see already, right? It already got this bucket policy where it says that it allows, this bucket will allow access to only these this particular entity, right? And this is what we created, right? CloudFront object identity, which we were just discussing as a CloudFront user, right? So that's what CloudFront is doing in the backend. So it will take some time, but I have already created a distribution. But let's try if it we got an endpoint or not. So we already see that if you click on there, you see a domain name, and now this web page or this website have some random string at cloudfront.net. So when you access this page, right? When you access this page, we have our index.html up and running, and you can actually access this page from your mobile or desktop now because it's available across the globe. But the good part is you don't see from which bucket it is coming, right? I have hidden that, or I have hide that behind CloudFront. So that is good, right? In terms of security, so you don't know who is the owner, or what's the bucket name and all of that, right? So CloudFront not only enables you to get a better performance in the form of caching, but it also masks your S3 identity, right? From which S3 bucket it is coming from, and all of this. All right, so this is what I wanted to show you on S3 side. Okay, so let's go back to our presentation. So if you have any queries, please do ask. Okay, so you have to make sure that we don't miss your questions. So let me. Okay, so before we go ahead, yeah, before we go back to our presentation, since we are already into our demo, let me show you EC2. Okay, so the services that we have learned so far are S3, CloudFront a little bit, and Cloud9. We have seen that's a virtual environment where you can have your IDE on the cloud. And now we are going to see the most important service, which actually we used when we used Cloud9, but it happens at the back end, and we will see now. And that is EC2. Okay, so EC2 is our virtual server service in the cloud. So if anyone says that create a virtual machine on the cloud, what they are actually saying is create an EC2 instance. Okay, so the way that you can create an instance is by clicking on this button, launch instance. And here you can select the type of instance that you want. So let's say if you are into machine learning, you can even search for deep learning. Okay, you want to search for instances which are good for deep learning. Okay, so let's select any of these machine. Okay, so let's say this one, Amazon Linux 2. So you click here, select next, and then it will tell you what type of instance you want, like what should be the configuration, right? So you can always come here and select different types of instances. So if you're new to AWS, you may not know what are these all types. So you need to check the documentation. But there are few instances which comes free in the free tier. So like T2 Micro, it's a tiny instance, but you can make good use of it if you are getting started. But let's use something little powerful. Okay, so let's say C5. So it has CPU, like 96 CPU, and it has memory up to 192 GB. Even you can take P3 instances. These are mostly used for machine learning. So it has 8 CPU and 61 GB of memory. So let's select this and click next. And we don't have to worry about all of these details now, but basically you can give lots of access control. You can define what type of file share, what type of permission that you want to give, everything you can define. So here you can add more volumes. So this is the root device, which is of 95 GB. You can always increase it to 100 GB or 200 GB, whatever you want. But let's go with the default. You can also add volume to this, like nothing but an, you can think of it an external drive or an added hard drive in your server. And then you can click next. Then you can click again next. Security group is again, everything in AWS is around policy and security. So you can define what port should be exposed, what port should not be exposed. It's kind of a virtual firewall you can think of, and you can select put any rule, like you want to have TCP open for all, or you want to have SSH open or SMTP open. This is basically the rule sets. Okay, we're not going to add anything, but you can do so. Then you can click next, come here, and then click on launch. Okay, so this is the final step where you need to define an SSH key pair. So you cannot log in using, we don't want to log in using username and password, because that is not very secure, and we want to use some SSH key. So you can always create a key, or you can choose an existing key. So I already have one existing key, and I guess that is past Linux. Let me see that. Yes, Linux passpem. Yeah. So I can click on launch instance. So now what is happening is it is trying to create an instance in the backend. And once this instance is available, I should be able to log in and start working with it. And this is what I was talking about when we started this session, that it gives you the agility to get started with your work very quickly. Okay, so the moment you get an instance, you just start writing your code, or you can start utilizing that for your application. And once you are done, or you feel that, okay, I don't want to use this, you can just destroy, right? So, and you pay based on the hours of, the amount of time that instance was up and running. Okay, so let's see what's the status. So as you can see that it is still in the initializing stage. It will take a little bit of time to come up, and once it comes up, we will get an full DNS name, and with which we can do an SSH. Okay, so that's about EC2 instances. And what is the advantage of why did we go with deep learning instance? I mean, what was the advantage? The advantage is, now when you log into your EC2 machine, you will have all the deep learning modules, or rather packages already installed. Like if you are into machine learning, you would know that there are packages like TensorFlow, PyTorch, MXNet. Those all things you don't have to install, like using pip install or whatever, right? Everything is preloaded. All you have to do is you just go and start writing your code. Okay, even you get a virtual environment where if you use Python, you know that we have something called virtual environments. So you can just enable that virtual environment and get started with it. So that's the beauty of EC2 instances. Okay, so we'll go back to the PPT, and we'll again come back here, and by the time, hopefully this initial check would be over. Okay, so let me just try out. So if you click on connect, not here. If you click on SSH client, and this is the command. Let's try out.
Sir,
Yes.
so there have been few questions in the chat. So,
Okay, just have a look. Just give me a moment. Just have a look.
yes.
Okay, let me just try to log in and show you that it's able to log in, and then we will go back to your questions.
Okay.
Yeah. Okay, I guess we have used user. Okay, so if you see now, we have already logged into the machine, and you see that all these are virtual environments which are already there. Okay, so you can just, what you can do is you can just source that. So you can just activate that, and it also have an NVD, GPU attached to it, since we used an P2 instance, right? So that comes with a GPU. So all you can do is, let's say you want to work with PyTorch. So where's PyTorch? Yeah, this is the one. So I just copy this, okay, and I just activate this environment. Okay, so now I have PyTorch in it. So if you see here, so So I have PyTorch already installed, and you can just get started with your code. So this is the first time, so that's why this import is taking a little bit of time, but you get the idea, right? So that's the beauty of using a deep learning instance. Okay, but it's similar to any other instance type. You can always select any Windows or even Mac, which we started to support. In the last reInvent, we just announced that. So reInvent is our annual tech conference, which happens in Vegas every year. So in that conference, we announce new features every year, and this was one of the feature that we support Mac. Okay, so there are some questions. Can we store any type of data in S3? Yes, you can store any type of data. It can be file, it can be folder, it can be any music file or whatever. It's, you can think of it as just like a dumping yard that you just dump your data, right? So you can always use that. Okay, so okay, I'm sorry, I'm just reading. There is a request called Zoom a bit. So I hope that it was okay. If not, you can just connect with me, okay? If you miss out something and it was not properly visible. If we create two VPC, public and private, is it possible without a NAT gateway? Is it possible without NAT gateway, or if I'm creating it through a NAT gateway, I can pay. I can pay as mentioned inside. Yeah. So basically, you need an gateway. You need a NAT gateway. Obviously, you need to have a NAT gateway, but you can always create two VPC or two different networks within your account, but you need to have an gateway so that they can talk to each other. But you need to be very careful, because your public a VPC will have an access to the internet gateway, right? So for accessing the internet, or installing any patch or something like that. And we generally do this when you have some instances in your private network, okay, and those instances do not have the visibility outside, and you want to update some patch, or update that operating system or any software. In that case, you need to have internet connectivity, but that virtual machine is in a private VPC or private network. So in that case, we create something called Bastion host, and that has the connectivity to the public internet, right? Through the internet gateway. So through that, you can always access. Okay, so what is the difference between private cloud and on-premise? That's a very good question. Okay, that's a good question. So see, this private cloud, public cloud. I mean, public cloud is still very straightforward. That it's some company has built a data center and they are renting out, right? Just like AWS, in a very nutshell, in a rough language. But private cloud is something. Uh, Various companies will define it in a different format or different way, but you can think of it as this. Let's say you have your company, and you are not using AWS or any cloud vendor, okay? But what you have done is you have purchased or bought some equipments which offers service sharing, Okay, so there are lots of storage companies who build storage, which you can share within that organization, right? So those companies can call their product as a not public cloud but a private cloud. You can think of it as a VMware, right? So if you think about VMware, if I install ECX in my server at my home, and I create 100 virtual machines, and I give all those 100 virtual machines to 100 of my customers, I can always say that, okay, this is my private cloud, right? Because it's kind of a hosting service, but all the hardware, all the infrastructure is within me, right? Within my data center. So you can think of that a private cloud as a virtualization. Virtualization is a much better term to define that. You have the software, you have the credibility, you have the engineering team within your company who can either use a ready-made product like VMware or ESX, or there are a lot of vSphere related products, or you have the engineering, or you have the people who can build software which can scale using just commodity hardware within that company, right? So you are not going outside from AWS or any vendor for services, but you have built everything within your premise. Okay, so just on premise and private cloud, it's not very different. It's not different. Basically, private cloud is a subset. It can be, it should be always within on premise, right? Because whenever we say on premise means anything, any hardware which is in your data center. That's all. Now within that data center, if your hardware and software is capable to do hosting service, then you can call that it's a private cloud, right? Otherwise, it's just an on premise. Okay, so any other question? Will user data execute when we reboot our system? Okay, I guess the question is, do you lose the user data when it's rebooting? So when you reboot an EC2 instance, right, your data is still there. It's persistent. That storage is persistent. But if you shut down your server, right, in that case, whatever data you have kept in the root file system, right, or the root directory, the root device, right, where the operating system is there, that gets deleted, okay, by default. Okay, so if you have attached a separate storage, then that data gets persistent. Even if you delete that EC2 machine, it's still you can always attach that storage to another EC2 machine. But if you create an EC2 machine, let me just show you. So if you see this EC2 machine, right? So if you come to this EC2 machine and storage, this is the root device, right? Root EBS volume or elastic block storage. When you delete this instance, this device gets deleted automatically by default. Okay, so all your data is gone. But if you have attached some external device, which you have just you might have seen while we are doing that demo, there was an option where we can add device, right? Those devices are persistent. Those devices stays even when you delete this. Okay, and those devices you can see in the left hand side under volumes. Okay? And then you can attach that volume to any new EC2 instance. Okay, so that's how it works. Okay, any other question? I see there is a question from Rishi. What is the difference between EC2 machine and S3? Right. So S3 is just an object-based storage. So where it is just a storage service where you can just dump your data. That's all. Right. And now S3 is integrated with all the services in AWS. So whenever someone is using some service within AWS, he has to use, he will be using S3. Right. But EC2 machine is and compute service. It's not a storage service, it's a compute service. So what do we mean by that? It's a virtual machine, right? So you can do anything that you could imagine that you can do in a server or your desktop or your laptop. Okay, so this is the basic difference. Okay, any other question? Should we opt for private or public cloud? So that's up to you. So it's about your choice that you make, right? So just like what we have discussed. Okay, so this got imported, right? So now if I'm just exiting out. Okay, so that I close this session. Okay, so now let's say you were using a private cloud, right, or on premise, whatever you call it. You must be buying servers first place, right? Without that, you cannot start anything. You have to buy servers, network gear, storage, everything. Now, do you think that that would be scalable, or you can do more experiments with that? The answer would be probably no. Like, just think about it. Just 5 minutes back I created this instance, but I feel that this is not the right instance, and I should come up I should have another instance, because this is p3 in type of instance. It has gpu, but I don't want gpu anymore. The project that I was working on doesn't need gpu. So I can come here and I can just terminate. Okay, so now think about it. Can you do this in your on-premise server? You cannot do that, right? Unless and until you have those kind of agreements that where you can go and exchange with respect to a new one and all of that. So you can understand, right, what the hindrance come up with, right? I would always encourage you to look into how things work in the cloud. But before doing that, being a student, what is best for you to imagine is how the same thing can be done on premise, and only then you can understand what's the trade-off, right? Or what's advantage, what we have as an advantage, because cloud and all of these were not there 20 25 years back, right? uh, but just think about it, how people were doing or developing products at that time and how people are doing today. And that's why you see today people are coming up with their products, services, startups so quickly. You pick any company, any startup or any company, even enterprise company, you will see that if someone is building something, their competitor come up with that same similar solution within a day or within a week. But this was not the case 20 25 years back, when I was in school, or you might have born in 90s, but that was the idea, right? So you get the flexibility and agility. Okay, so any other question? Okay, I guess we are good. So let's go back to our slides. So the reason that I want to show you the demo and hands-on, because PPTs are not that appealing, and I'll probably skip the later part and I'll go to another demo. Okay, so these are the broad range of services. This slide is just to check that you are not colorblind, because I myself have not read all the services, and I honestly I do not know almost half of these services, and I just know what they do, but I've never worked on it. But the idea is you have different services for all your problems or all your use cases. Like for IoT you have different services, for machine learning you have different, for storage you have different, everything, right? Now there are there's something that you always should keep in mind, and that is some core service and fully managed service. Okay, so when we talk about core service, that means very just like in programming we say that write the program using first principle, right? So core services are like that. So when you think about EC2 machine, that's a core service. Okay, when you think about S3, that's a core service. When you think about VPC, that's a core service for networking. So these are the fundamentals. Okay, now there are other services which are fully managed, and those can do most of the things for you. Okay, all you have to do, maybe you just have to use them as an API, or you might have to integrate with your application using API, or you can just dump your data and start using it, right? So those are fully managed service, and we will see a few of the demo in the machine learning side in maybe, if time permits, in 10-20 minutes. But most of the services that we have are managed service, and we always recommend to use managed service, because you don't spend auxiliary time to focus, or to focus on multiple things, right? You should just focus on things that for that you are hired, or which you are passionate, or the problem that you are tackling, right? So let's say you are a programmer, you really don't want to mess around servers, networking, and all of that. It's always good to know, but you always dream that, okay, I will just come inside my room or my office and I will have a system where I can just start my code, right? Rather than thinking about what server, how to manage, how to scale, networking, all of that, right? So that's the difference between fully managed and core services. So now we have seen different ways that you can access AWS services. Like Web Console is one of the service. AWS CLI also we have seen, but we also have SDKs. Okay, so this is the most commonly used tool for any developer. So we have SDK for with Python, with Java, JavaScript, .NET, etc. And we are going to see using Python how we can access AWS resources. But we do have. Similarly, we have IDE, which you have already seen. We have Cloud9 as an IDE environment where you can go and start using the resources. And we also have some infrastructure as a code or an automation tools like CloudFormation or CDK and stuff like that. But those are mostly towards the infrastructure side. So if you are managing the cloud infrastructure on AWS, you may like to use those. Okay, so that's how you access. So how you can get started? We have free tier. Free tier means not every service is free, but majority of the services that you would need to get started with, those comes free in the first year, and with some limitation, but it's quite high. You don't have to worry about all of that. And the I think this is one of the challenge which I always hear from students, especially that to create an account you need to have a credit card, and most of the students do not have credit card, right? And they should not as well. So, but that's a problem, I know. But there is one alternative is if you are a student and if you have a college email ID, not the Yahoo or Hotmail or Gmail email ID. If you're an college email ID, you can create your AWS account using Educate program. So you can just search AWS Educate, which will redirect you to a page where you can just give your college email ID, and you can get an account free of cost, and you will get $100 credit, as well as there are lots of trainings are provided to you. Okay, so that is something that I just want to keep you aware of, that in case you have an college email ID, you can make an account without any credit card. Okay. All right. So we have seen a lot of we have just seen one of the compute service, that is EC2, but there are other compute service. So now when we think about compute, just think about where we can run our code, right? Or where we can run our application. Like EC2 is surely one piece, but there are other services that we have where you can use as a compute, where you can use as a compute. And other two which are mostly prominent are ECS and EKS. So these are container services that we have. If you are new to container, you can think of it as not a virtual machine, but the way that container works is, it doesn't need an operating system from infrastructure standpoint. So let me show you what I mean. If you know what a container is, then it's good, but they're just for people who do not know containers, so, or new to containers. So you can define container as a developer. The definition would be different. You can define container from infrastructure, okay, and the definition would be different. So what I'm trying to explain now is from an infrastructure standpoint, okay. So in EC2, so let me just take an yes, this should be good. Okay, so what happened is when we first got virtualization, right? Before virtualization, we used to have a server, right? And it used to have an operating system, right? And let's say this was Windows or Linux, and then we used to run our application on top of it. And then let's say this is Windows. If you want to have Linux, then we used to buy another server, right? We used to buy another server, and this was Linux. And again, we used to run our application, and this was going for last many years, right? And then we got into virtualization, all thanks to VMware. Even it was there before VMware came in, but VMware has just changed the whole dynamics. And what they said is, why to have different operating system in different servers? Why can't we use a single server and do some software? And this is the software which the VMware provides, right? Like vSphere, ESX, or any of its software. And then you can have different virtual machines, and all this virtual machine can be Linux, Windows, or anything, right? So now we solved one problem, that you can run different application on your single physical machine with different operating systems, right? So this is working pretty good, and this is how people have been using virtualization for many years. But now there is still some problem. Not problem, there is still a scope of improvement, that all I care about is this application, right? So what if I do not need to have any of these different operating systems? Because this is still an hindrance, right? If you think about from an application standpoint, I still have to install a separate set of operating systems, which is again an overhead. And that's where a container comes into picture, right? So now what container does is, you have the same physical server. Okay. Now this was an operating system which was, let's say we take an example of VMware, right? And on this operating system, we are able to create virtual machines where we have to have a different operating system for different virtual machines. But now what containers can help you with is, you pick any server, you install Linux or Windows, whatever, and then you can just install some container orchestration or container software. Okay. And this software can be, you might have heard, Docker, right? Or there are many other tools, but Docker is the most predominant. And this software layer, this small layer of software, gives you the ability to isolate your memory and CPU within your server. So now what happens is, to run this application, you wanted to have a Linux platform, right? So you can just create that application, and this application will use some memory and CPU, which will be completely isolated with respect to another application. Okay. And all this isolation can take place only because of this Docker software. Okay. So the only dependency is, now you can run all the applications which can run on Linux on a single machine, and you can have another server where you have this Docker software running, but that is a Windows. So you can run all your applications which are Windows platform based in one server, and all the applications which are based on Linux can run on another server, right? Although you can run Linux container and Windows container these days on a single machine, but ideally people do not do that. So we started from here, and now we are here. Okay. In fact, we have gone one step ahead. Okay. So in this case, we have to do is, we have to create a server, right? Or have a server and install Docker and create containers, right? And this is what this service is, EKS and ECS. Okay. These are the container service that we have, where it will create the EC2 machine. So it will first, what EKS and ECS is, EKS is for Kubernetes, ECS for containers. So what it does in the backend is, it creates an EC2 machine. Okay. This is an EC2 machine. It will create one EC2 machine for you. On top of it, it will have that Docker container runtime installed, and then it can create small containers. And these containers you can use. And all this management can take place using ECS or EKS if you are using Kubernetes, which is another orchestration software. Now, if you think about it, although you are using ECS or EKS, you still have this EC2 machine. You still have this, although you don't manage it, but you still have this, right? In the backend, it will still get created, and you can still see that. So now what we have done is, or what the industry has come up with, is something called serverless. That means all you need is the application or code. Okay. The moment you have the code, you can just AWS will automatically create an instance or a container which is needed to run this code. Okay, so that means now you don't have to even create EC2 this ECS cluster or EKS cluster, nothing. Okay, all you need is your code, and in the backend it will automatically create some container for you, and it will run. And once this code execution gets over, it will just destroy this container. Okay, and that is what Lambda is about. Okay, that's what we call it as a serverless compute. It's not like there is no server, but that is, you don't see that, you don't manage that. Okay, all you care about is the code. Okay, and we are going to see that in the demo next. Okay, so I just wanted to give you some intuition of containers, how we started. This was back in the 80s or 90s, sorry, 80s or 90s, or even we have used till early 2000. And then we got into virtualization, which kicked off in 2000. And then we have container, which is like mostly it came up in after 2015, or even before, I think 2012 or something. And now in as we speak in 2021, we have mostly serverless, okay, or Lambda. Okay, so this is the thing that we are going to discuss. So Lambda is not the only serverless service. We do have many other serverless service, but from compute standpoint, Lambda is the thing. So let me show you that, so that you get a better understanding. Okay, so let me close all of these. Okay, so let's come to this Lambda demo. Okay, but before we come to Lambda demo, I want to show you how it looks like in the console. Okay, so again, I'm in the home page. I guess now I'm zooming a little bit more. So you can search for Lambda. As it says, run code without thinking about servers, right? That's the whole objective. And I'll give you one example of Lambda, which you might resonate well, but I just want to show you, how to create a Lambda function. So again, we will be creating a Lambda function, but this time not using CLI, but using an SDK, and we are going to use a Python SDK. Okay, but before that, let me give you an example. So you might have seen, let's say, I'll just show you. Let's say I want to convert a doc to PDF. Okay, this is something that you often do it, right? And what you do is you may be searching for this, and you can come to some website, right, like this, and you can upload your Word file, and just it will convert that file into PDF, and you are done, right? Now, think about this. Let's say you are developing this application for your company, and this company is ilovepdf.com, right? So your focus should be how you can convert a Word file into PDF. So your program, or you will be coding only to solve this problem, right? But now uh, that is not it, right? You need to deploy that. You have to make sure that this website is up and running, and you get the request from HTTP from all the users and all of this, right? So you have to work on that as well. Now, let's say you have done all of this. You bought one server where you have deployed your application, which you have written, okay, which can convert a Word into a PDF file, and you have hosted that as a web page. And this is the web page that I've logged in. Okay, just assume that this is your software, and the server that this software is running is in your house. Okay. Now think about it. I will use it now, and I might be done, and I will close it, right? At that point, your server is completely idle, right? It's not doing anything, but still it is using electricity. You are paying for the bills. Your server is not getting utilized. So you may think, you may say that, hey, you have closed, but maybe some other user is using it. That's pretty correct. But what about at night time? No one probably in the night time will use your server, right? People will be using it during your daytime. So what if, so this is a problem, right? You have to maintain the server, the cost is high, because not everyone is using all the your application all the time. So that's why people came up with something called serverless, and hence Lambda. So let's say you deploy this application using Lambda. What would happen if you deploy this application using Lambda? What would happen is you will deploy this function as a Lambda function in the, or when I say deploy a function, you can think of it as a deploy your application. Okay, when you deploy your application, same application, as a Lambda function, what would happen is there won't be any infrastructure on AWS which will be created for you. Nothing. Okay, all AWS will have is your code. It will just have your code. Now it will be triggered only when someone accesses this web page. Okay, that means the moment I, let's say I close this, okay, and I open this again, the URL, and I hit enter. The moment I hit enter, now what happened is, behind the scene, a Lambda function, this Lambda function will get triggered. Okay, and that will create an instance or container, to be precise, for your application, and it will run your software at that point in time. So the way that it would work is, when I click on select some Word file, it will upload that file, and the Lambda function will be watching some place. Okay, maybe it will be looking to in some S3 bucket. Okay, I have to kick off my container the moment there is a file in this bucket. Okay, it will just watch. So that's why we call this as a event driven architecture. Okay, so Lambda is an event driven architecture solution where you write your code, deploy your code, and then you just define that your code should kick in what trigger. So for this particular application, I will say that okay, trigger this application only when you see a Word file coming in some S3 bucket. So this Lambda function will look at this S3 bucket and see the moment there is a doc file, it will just trigger that. Okay, so so in that case, your application will run only for the duration that it would need to convert this file to from Word to PDF. Once that is done, the moment that operation is done, the complete infrastructure will be destroyed in the backend by AWS. Okay, so you can scale your application. Doesn't matter at what time people are accessing your web page, you still save page, and it is very, very scalable, right? So you don't have to worry about the scale. Now, how you can create a Lambda function? All you do is come here, click on create Lambda function. You can create from scratch, or blueprint, or container, or you can have your repository. So those all things are like, give you more flexibility. But let's say author from scratch, you can give some name, let's say my demo, and you can say what language that you want the runtime to be. So let's say Golang. Okay, and that's all. And you can just click on create function. Okay, so now what is happening is, it is not going to create any server or container. Okay, this is all happening on AWS, right? So the moment you create a Lambda function, nothing happens. It starts to trigger only when it starts to work only when there is a trigger. So as of now, there is no trigger. If you see here in the UI, there is no trigger, and there is no code as well, right? I have not written any code, so I can always write code here. Okay, so this code editor is not supported because I've used latest one. So let me just create a Python one. So let's say my demo 2. Okay, and let's say I select Python 8.3.8. So what was happening is, this Golang we just supported, and it doesn't support as of now. It doesn't support this version in the code editor. Okay, you can always do that in your editor and push it to AWS, which we are going to do in the demo. But it was not available in the console. Like here, let me zoom out a bit. As you can see here, I've created a Python Lambda function, and I see that the editor is there, right? And this is my Lambda function. Okay, this is a boilerplate code. You don't have to worry about this code. Let me zoom a little bit. Okay, so basically you can just write your code here. Okay, whatever your code is, you can just write it. Okay, now this code, this particular function have two arguments, command line arguments. One is the event, another is the context. So event is the main thing. So this event is nothing but the event that you add here, right? So when your Lambda function should get triggered, okay, you can define. So if I click on add trigger, you will see that there are lots of different triggers. Okay, there will be a trigger for S3. Okay, and I can define which bucket, right? Let's say this random bucket, and I can even say, okay, I know that you are telling me that I should look into this bucket, and but tell me what should be the event. Should that be a post event, put event? What should be the event? That means whether I should trigger myself on an addition of a file or an update of a file or a deletion of a file, when you want me to get activated. So all of these you can set and then you can add. Okay, so we are not going to do that, but that's the idea. Let me go back to the functions. I just clicked on the wrong tab. Okay, so you can always write your code here, and this event contains that trigger, and context gives some metadata about that trigger, right? At what time that function got triggered, so that you can do some housekeeping. Now, you may think that your application might need lots of dependencies, right? Like you are using some third-party package. Let's say you use some third-party package, right? Let's say PyTorch, okay, or maybe you use a pill, right, for image processing. So all these things are not there. So what you have to do is you need to create a new file, requirement.txt, right? And you have to give those, all these libraries, you have to put it here so that it gets installed. So there should be some better way than coming here and managing all of this. And surely there are better ways to deploy Lambda functions, but and we are going to do that in the demo now. But I want to give you an idea that no one create a Lambda function using UI. Okay, everyone use some GUI or some other tools, right? But you can always do that when you are getting started. You can always do that. So let's go back to our demo, and before that, let me just delete this because this is just a demo. We don't want this. We're just deleting these functions. Okay, so now what we are going to do is we are going to use a third-party library called Chalice. Okay, so Chalice is a third-party library which is developed by AWS to deploy Lambda functions on AWS. Okay, so I'll tell you that why you should use a tool like Chalice, or there are different tools. I can always redirect you to different tools, but Chalice is the tool which people use when they work on Python. Okay, this is only for Python. If your application is in .NET or Java, you can use other tools. So for this, what we have to do is what we can do is we can go to my Lambda demo. Okay. Now the first thing that you need to do is you have to install Chalice, so which I have already installed, and I'll show you what Chalice is. Okay, it's just a wrapper in Python. Okay, so now what you have to do is you can say Chalice new project and give some project name. Okay, so I've just created a new project, and the name of the project is my Lambda demo. Okay, so now I can go inside my Lambda demo. So still now I'm still in this machine. Okay, there is nothing, no Lambda function created, nothing happened. Okay, I just want you to see that what is the flow. Inside that, you already see that there is an app file and there is a requirement text file. Okay, it automatically got created. I did not do anything. Okay, so this is the place where you have to write your code, and this is the place where you can write your dependencies. Okay, so the problem that we are trying to solve now is for this particular demo is we want to create thumbnails from an image. Okay, so given an image, it will create a thumbnail. Okay, this is the application that we are trying to develop. So now for doing so, first we have to have the requirement files, right? Because I will be using some third-party libraries, and I want to make sure that those third-party libraries are mentioned in this requirement.txt. So I can always come here and click on requirement.txt, which is an empty file, and I want Boto3, okay, and pillow. I'll tell you what Boto3 is in a moment. Okay. And pillow. So now if you come to this requirement file, it contains both this library. So what are these two libraries? Boto3 is the Python SDK to access any resource in Python, in AWS, okay? And pillow is the package which we are going to use for converting that image into an thumbnail, okay? So let me show you the code so that you would get a better understanding. So I'll double click on this app.py, and it will have some boiler code, and I am going to delete all of these, and I've already created that app, and I'll just copy paste this. Okay, so it's not a very large code, just a 20-25 lines, but it's very simple. Okay, I'll just walk you through quickly. So we import temp file. This is a module which can help you to create temporary files. Boto3 is to access any S3 Amazon or AWS resource in your account using Python. Okay, this is the package that you need to use. And that pillow, when you install pillow, you get a module called pill, and inside that we will import image, and then chalice. Obviously, we are going to use chalice. So now first is we are going to define a chalice object, and that's what we are defining as app. Okay, if you're new to Python, that's okay. If you don't use Python, just follow me along, because it's pretty easy. You can use any language for that matter. Okay, so this is the application. This is the actual application instance I am creating using chalice. So now I'm not going to Lambda function, create Lambda function, and writing my own function here. So I'm using chalice. I'm telling chalice, hey, just create this application and name this application as this. Okay. Chalice is just a wrapper around the Lambda function utility, right, that we have. Okay, so just think about it from that perspective. And then we are using Boto3, and we are going to use S3 for this. Okay, because we want to make sure that our code gets triggered only when someone uploads an image into a bucket. Okay, just like the example we just discussed, that when you convert from PDF to Word doc, you may trigger your code only when you see a PDF file coming or a doc file coming into a particular folder, right, or a S3 bucket. So we are going to use S3 for this. And this should be my input bucket name, and this should be my output bucket name. So let's go to this bucket and see that if there is anything inside. So let's go to S3. These buckets I have already created. So if we just go to this bucket, there's nothing inside. Okay, and there is another bucket called output. And if you come here, there is nothing inside. So both the buckets are empty now. So we are good. So these are the two variables I've stored. And then comes my actual Lambda function. Okay, so this is the same function which we have just seen while we were showing that in UI, but I just renamed this, right? So this is just a function name, and we are using a decorator. Okay, so if you're new to Python, you can think about it as a wrapper around your function. So basically, what we are saying is, we are calling this wrapper as decorator as app, which is my chalice application, and we are saying this app should get triggered on S3 event. Okay, that means we are saying this code should trigger only when there is an S3 event, and on which bucket? The input bucket. So what we are saying is, whenever there is an object. So whenever there is a put call on this bucket, just trigger. Okay. So this we are saying by this decorator. Okay, this is what we are saying in this decorator. Whenever there is a put call on this bucket, just activate. Okay, and what we are doing, we are just in the first line number 14, we are just putting a log message just for debugging purpose, that resizing of the image from this bucket. Okay, because this event will contain all the details about this event, right? So if you want to access this bucket name, you can actually access through event.bucket. Similarly, event.key. So event.bucket would be this name, right? And event.key would be that file name, that whole, you remember this, which I was showing you when we were talking about, just one second, when we were talking about S3, right? So this is the object, right? This full object, okay? And this is the bucket name. Okay, so with this, we will use a temp file, and we will create an S3 object. And this S3 client we have already created here, right? Now we are saying that, okay, so now we want to download an S3, a file from S3 bucket. So we are using download file function call. We are passing the bucket and the key and the file name, and we are creating a new file name, because after resizing it should have a new file, right? So we are just putting an extension to thumbnail.jpg, and we are using this image package now, which we just imported here, right? And we are just converting it into a thumbnail of 256 by 256. And lastly, we have to save that file back, right? So we are saving it into the output bucket, right? So we are saving it here. Okay, so this is the output bucket, and this is the input bucket. That's all. Okay, we are not doing anything fancy here. So that's about the application. So let me save this, and I'll close this. Okay, so now we are done with all of this, right? So what we have done is we have created that function, we have updated the requirement file. Now we have to do is we have to deploy this Chalice application. All right, so in fact, we need to install this requirement file as well, but I guess I've already installed, but still I'll just install it. It doesn't matter. So now what we have to do is we have to run Chalice deploy. Okay, that's all. So I can run first. Let's see what are there. So if you see that in this, we just have two files, but if you see, you see there is some hidden files here, right? .chalice, and inside that there is all the configurations are maintained, like what is the account, where I should deploy this in AWS, because I already using AWS CLI. So Chalice copies everything from AWS CLI configuration. Okay, so it knows my login credential, what is my AWS account and all of this. So only thing that we need to do is do Chalice deploy. Okay, so now what is happening is there is some syntactical error. I guess there is something wrong. So here is dot. So let's rerun this. Okay. So what is happening? What happened? Again, there is a. Okay, let me. Okay, here also. How it got. Sorry about that. Okay, looks good. So let me close this. Okay. So now what it is doing now is it is packaging the whole thing, and it is creating a zip file. Okay, and it is now going to create that zip file which contains that app as well as the requirement file, and it is going to create an IAM role, which while we did the UI, we just clicked next and it created an IAM role for us, and it will now get deployed on AWS. Okay, so we don't have to do anything, on AWS console. So now let's go to Lambda. Let me open this because this is the object S3. Let's stick to this. I'll open it here. So let's say Lambda, and here you go. Okay, so you see that it's got created 30 seconds ago, and we already have a Lambda function. Okay, so now you cannot edit this function in this console, and you see that there is already an S3 trigger, and this is because we defined that in using Chalice, and you cannot edit the code here. Okay, because it has zipped folder, and you cannot edit all of that in the UI. Okay, that's why it says that the deployment package contains is too large to editing in this online editor. Okay, on the UI editor. So now that we have created this Lambda function, what we can do is we can go to our S3 bucket and go to this input bucket. And here we can upload some image, right? So I have an image on my desktop. So let me drag and drop and upload it. So it will take a couple of seconds to upload. And while it is uploading, let me show you what that image looks like. So this is a big image, right? And we are trying to convert that into a thumbnail. So now this image got uploaded. If I now go back, and again, if I go back and if I see this output, okay, you see this? It just got created now, right? It's 6:45. And if we just download this and see what this file, and if you see this naming is still like that, what we have written in the code, it should end in the thumbnail.jpg. And if you click here, it created a thumbnail. Okay, now you can think of this application can be anything, right? It could be PDF to Word or Word to PDF, whatever it is, right? And you may not even want someone to upload a file in S3 bucket. You might create an UI for that, just like the website that we were accessing, right? But you get the idea. Now your code execution got over, right? So now you're not charged, and now Lambda is not running anywhere. Your code is just like lying around in AWS securely in your account, but you are not getting charged. Let's say now hundreds of people are accessing this bucket and putting a file. At that time, it will create 100 such instances which will do this conversion. Okay, and that's why we say that in AWS things get scaled. You can scale up and scale down dynamically without any hindrance, right? So that's the beauty of AWS Lambda. And if you see here, you can even see if you go to monitor, and if you see in the CloudWatch log, you can even see there is a trigger. If you see this, there is a trigger happened, right? So you can see all those things in the UI, that how your trigger is happening, what is the traffic that you are getting, etc. So let's say you are done with your application, and now you want to destroy your application, right? Everything you want to destroy. So what you can do is you can just say Chalice delete. Okay, and it is going to delete everything, whatever has been deployed. So you don't have to go back to the UI and do that deletion. So now if you come here and come to function, you will see that Lambda function is not there. Okay, it got deleted. So that's about it. And I guess there's one more thing. There's one more thing I wanted to show you, that is on database, but that is okay because that is not that important. But I'll just tell you that in brief in a couple of minutes. So we discussed about AWS Serverless and AWS Lambda, but we do have many other services which are serverless in nature. So Lambda is not the only service which is serverless. Like that, we have API gateway service, SQS, for queuing, SNS, for messaging, step function, etc. I mean, these all are fully managed service. Okay, so you don't have to worry about all of that at this point, but you should know that these services exist. In fact, S3 is also an serverless service, right? So because you don't manage anything, everything is on the cloud. And you even have database like DynamoDB, which is a key value pair database, which you might know as a NoSQL database, which you can use on AWS, and that is also serverless. Okay, so last point I want to, last thing that I want to tell you is we spoke about storage, we spoke about compute. The only thing which is vital is to know about database, right? That is something that we use every day. So there are different database depending on different use cases. If you are using a SQL kind of environment where you want a relational database, you can use Aurora or RDS. If you use key value pair, you should use DynamoDB. Then we have DocumentDB, Elasticsearch, which is for in-memory. Then we have some Neptune database for graphs, for time series, for blockchain, QLDB. Even I have not used any of these. Okay, I just know that they exist, but you get the idea, right? You have plethora of services which caters a wide variety of features of when it comes to database. Okay, so that's about it. And since we have so many database and so many storage services, we know that there are a lot of data coming in from various sources, not only by by you and me, but also using IoT devices, servers, and all of that. So there should be some mechanism where you can just look into that data and do some analysis, right? So that's why we have lots of various analysis service like Athena, Kinesis. So these are very advanced level services which can read through all of your data without telling that service that what type of data that you have. And oftentimes you don't even know what type of data you have in your production, right? People can just upload data in different formats, PDF, images, whatnot, right? So you don't know. So these services can take care of all of this. So that's all about it. And I just wanted to share one last thing is on machine learning, but I don't think I have time. But if you have any questions, you can ask me. But before I end, I want to show you this. Okay, so there are different certifications that you can do in AWS if you are getting started with. I am personally is not a very big fan of certification because that doesn't matter. All that matters is how much you understand. But I like certification because it can give you a track to study. Okay, so I would always recommend you can pick up any certification of your choice and you can study in that direction. Okay, otherwise if you just jump in and trying to start learning, it is quite overwhelming. You would not know which way to go for. Okay, and later on, once you are done with your study track, you can write the examination or you can skip it. That doesn't matter, in fact. Okay, so you don't have to worry about that. If you write the exam, then that's good. A lot of students these days do that. But these are the certifications that we have. There are very good trainers available outside. If you need more information, you can ping me. I can guide you through. Don't spend money unnecessarily on different training courses. That doesn't I would not recommend. There are lots of resources available online as well as in YouTube. Wonderful people have developed lots of content, so you can make use of that. Or you can ping me. I can help you with more resources. But this is something that you should be aware of. And there are lots of user groups that we have in India. Maybe near to your city, you can pick one, maybe Kolkata or Delhi, whichever maybe your hometown, and you can start joining as a AWS user group member, or even you can become an AWS user group, not AWS user group, AWS community builder or AWS hero. These are very elite class programs for community members. You can always join. Many in our student a portfolio, like there are lots of students who have this community builder and community hero under their portfolio, which will surely help you, to get a better job, or if you want to start off something of your own, that would give you a lot of confidence, because being a part of this wonderful community will enhance your exposure to a lot of people, not only within India or within your city, but across the globe. Okay, so that's all I have. I do have few other auxiliary things, but those things you know better than me, like few of the events. But I really don't want you to waste your time. So I'll just take a few more questions if we have any. I guess we have few questions.
There are few questions.
Can you use CloudFront for dynamic content as well? Yeah, sure. So you can think of CloudFront as caching mechanism. We have just deployed a static page, but it could be always dynamic. That content might change, and that's why when you access CloudFront, you may not get the updated data. Just like we have in not, if you use Linux, we have something called cache invalidation, right? So here also we invalidate data based on some time period, right? We call it as a time to live. So let's say your CloudFront distribution has a time to live of, let's say, 100 seconds, or let's take a bigger number, let's say 10 minutes. Okay, so that means your CloudFront, all the CloudFront regions across the globe will have your data, and it will not go back to the origin for 10 minutes. Okay, so 10 minutes is the time to live. But let's say in the origin you have changed something. Okay, and immediately after that someone tries to read, so it will, he or she might get up older data, right? So we call it as a eventually consistent or consistent data, if you are from database side. But there are ways that you can mitigate. There are ways that you can work around, but you can always have dynamic content for CloudFront. What's the next question? Okay, so I right now in my first year decided to opt for CCVT as my specialization. So how much is it the scope? Can you just explain what CCVT is? I'm not that aware.
It is cloud computing and virtualization.
Okay. So is it a course that you have?
Yes, sir. It's a specialization course in UPS of
Okay.
computer science.
Okay, great. So yeah, so you can always do that, but always remember this. Okay, this is I'm telling you from my experience. Your this 4 years degree is very, very important. Okay, and when you go for any good company, and first of all, don't go by company names. Okay, it's not like Amazon is a big company, that means they are good. You should not think about that. Okay, just think every company is just like a place where you can work. All you should care about is what you want to work on. Okay, your passion should be towards your work rather than just a company, right? So now when you think about any good company, they will always look into fundamentals. Okay, so no matter what's your specialization is. Okay, so whether you are from CS background, non-CS background, doesn't matter. They will still look into your data structure, algorithm, operating system, networking, all of these, right? So uh, if those fundamentals are strong, or I mean, strong is again a relative word. If you feel that these are you have a good grasp on, then you can go anywhere. Okay, trust me. It doesn't matter what you have. Whether you have a certification or specialization, those things all comes later. Now, as you said that you already have a cloud specific degree, or you have opted for it, nothing like it. You should leverage that. Okay, so now you should be one step ahead of others, but provided you meet that ground requirement, which is data structure, algorithm, and all of that. If that is strong, on top of it, if you have cloud understanding or AWS understanding or anything of that sort, that would be an icing on cake. Okay, but it's not like just because of cloud computing specialization, there is a specific things that you might achieve. It's not the way that people work, or the industry think about. So just leverage this to the next level, because you took a good decision. You just want to make sure that just stay humble with that decision, that when you think about other basics that you need to cover. Okay. Yeah. What's the next question? How to do auto scaling if the average if the load average is high without downtime. Okay, so there is no downtime. You will not find any downtime. So this question, from the statement, I assume that you're talking about EC2 instances, because these things can be for any other service. So if you have one EC2 machine, right, or two EC2 machine, and those EC2 machine are in an auto scaling group, and now your workload is increasing. It adds more. The AWS will add automatically more EC2 machines under the belt without you knowing about it. Okay, so there is no downtime in any of these things, even if the workload is high, right? So because auto scaling will kick in only when the workload is high, right? So it will never kick in when the load is low. It can when the load is low, it will descale. So it will shut down few of the infrastructure, right, or few of the instances, but it will always kick in only when the load is up or down. What is the role of cloud computing in DevOps? Okay, that's a good question. So there are a lot of opportunities these days. Okay, with DevOps. So I would recommend that if you are into first year or second year, just find that what passionates you more. Okay, there are a few people who are very good at coding, and even if they are not good, or they are still learning, but they are passionate about coding. I would always recommend that go with your passion. It's not like if you don't know coding, or if you're not passionate about coding, you cannot do better. Okay, so there are hundreds of opportunities in the computer science business where people can do wonders in different roles. Okay, so don't just compare yourself with your teammates or colleagues, or don't get biased with coding or non-coding. I mean, because this is a mental block which I myself have seen in my personal life, but also I've seen from a lot of students. So there are a lot of opportunities. Okay, now when you talk about DevOps, if you're into first year and second year, and if you're passionate about coding, I would recommend that you should focus on coding, and you should eye for a development work. Okay, a software development work, or a software development role. Let's say you are passionate about coding, but you feel that you can do much more, and other things apart from just coding for application. You love networking, storage, infrastructure, basically. Then DevOps would be a great role. And DevOps, you can think of it as a kind of, the coding bar would be little less with respect to a software development engineering role, but for DevOps, understanding of infrastructure is much more needed. And one of the scripting language, or knowing some tools, like let's say YAML. YAML is not a tool, but you should have a decent understanding of YAML, or a few of the tools like Ansible or Docker or Kubernetes. You just pick one of them. Okay, you don't have to learn all of this, but just pick one of them, and that would help you a lot in a career, especially in the cloud. Because DevOps is one of the role which I see. I've seen last 2 years a tremendous growth, a lot of opportunity even within AWS. So if you are looking for any opportunity, you should join us as well. But you can think about DevOps as a, you need to know how to code, or at least read a code. But it would be great that if you know some YAML or Docker or container, because those things are fundamental, right? And you should have a passion towards infrastructure, like how a computer works, how a virtualization works, how networking works, and stuff like that. Okay, so do we have any questions? Any other question?
No, sir, I think.
Okay, great. So feel free to reach out to me over LinkedIn or Twitter. You can just search, it should come up. Uh, so uh, this is the my official page. But you can click on LinkedIn, and you can reach out to me. Feel free to ask any questions. And this is the GitHub repo. I'll just paste it. I will paste it in the chat. Maybe the organizer, maybe um, they can share this link so you can try out these demos. But not only this, there are lots of workshops available. You can do it online, and if you need any help how to get started, please reach out to me. I'll try to help you. Okay, so with that, I'll share it back to you, Ramya.
Thank you so much, sir. It was a wonderful session. I think we all learned a lot. For the certification, feedback form is description in the description below. Okay. So yeah, thank you so much, sir.
Thank you everyone.